Hello guys, am I audible? Please confirm if I am audible so that we can start the session, guys. Please confirm if I am audible. Guys, please be a little fast so that we can start the session. Be a little fast so that we can... Okay, so today actually we are going to start with the topic of what set theory. Okay, set theory plus Venn diagram is what I would actually like to refer it as, plus Venn diagram. Okay, this is what I would actually prefer to call it. Okay, because that would be the major portion of it. Okay, so LRDI, in LRDI, this is a portion actually of LR. Okay, first thing, and the second thing, set theory is also a portion of cognitive aptitude, in which it is a portion of modern maths. Okay, so we will try to cover both the worlds together with you so that it becomes even crystal clear how to use and when to use and how to formulate such portions, right? So set theory is little different when we do the questions based out of OMET, the other management entrance tests there are apart from CAT. For those, the type of question that will be discussed, we'll be discussing in our next class. Okay. In today's class, we'll be focused on how set theory and Venn diagram is rated in cognitive aptitude as well as logical reasoning examination of CAT. So today would be a CAT specific pattern that we'll be discussing with you. Okay. I hope it is clear. Now, there's something about us. If you have not already purchased the course of LRDI, please do that, because you'll not be able to just see the lecture once. You can always revise, go back and see how did we solve this particular question. Okay, in the YouTube classes you'll be able to see them only once. Okay, because what happens is when you are seeing a particular caselet and you are trying to solve it with us, then what happens is that when you will be revising the same caselet again or a similar caselet you are solving, then you need to go back and refer to what we discussed in the particular caselet of ours. Okay, so download the ANC app, get the free content, understand how useful our sessions are for you, and based on that you can always purchase the courses. Okay, this is something about me. I have been a 99.5 plus percentiler 5 times in the last 7 years that I have given CAT. The 2 years I did not give CAT, and I have been mentoring my students for 8 plus year. I have actually been teaching professionally from the last 11 years, but I would the first 2 to 3 years I was already preparing myself as well, so I'll not count that portion of mine. Okay, so again, I have mentored more than 2000 students till date. Okay, in various coaching institutes and also my own. So this is the most important portion, which is please sit with a pen and paper. Okay, the more you write right now, the less you would have to write in your actual examination. Okay, so for any doubts you can always mail us. Okay, this is anandayaclasses@gmail.com. Okay, and you can always WhatsApp for more details on our courses. Okay, now Please do attend all the classes that we are taking and also see the recordings if you have missed the class. This is only available with the enrolled students of ours. Okay. Other students will not be able to see this particular recording, because as soon as the session is over, we have to make our classes, the YouTube class, private. Okay. So please attend these classes, because they will be very useful for your preparation of CAT examination and other management examination as well. Okay. So we'll define, the first and foremost thing is we'll define, and then we'll go to the basic foundation level problems, then to the intermediate, then to the advanced, and then finally to the exam level model of ours. Okay. Now, not just that, we will be actually defining what are sets to the very basics and to the very core of it. Okay. So before doing the first question, let me just add a particular blank page to be able to explain every detail to you. Okay. Perfect. So what is a set? Okay. If it is denoted by a capital letter, and the definition or the values or that belong to this particular set are put into these. Okay. Okay. So this is an example of a set. Okay. In the example of a set, I can also write this particular set as a definition. Okay. I can also write this particular set as a definition. How? I would define X is such that X is equals to n square, where n is more than 1, n is more than 1 but less than, let's say, 7. Okay. And I should also write actually the whole part of it, and n belongs to natural numbers. Now, more than 1 means 1 is not included. More than 1 means 1 is not included. So the next natural number after than 1 would be 2. So 2 square would be 4. So the first term came. 3 square, the next term would be 3. So 3 square, 9 came. 4 square, 16 came. 5 square, 25 came. 6 square, 36 came. Okay. I was not supposed to take 7 here. Why? Because it is not included here. Okay. Now, to define something like this, I have 3 methods of doing that. Method number 1, I can write it as only brackets. Means only the elements which are a part of this particular set would be written here. So 2, 3, 4, 5 and 6 would be written here. So this is a part, only elements which are a part of this particular set. Okay. The another way of writing it could have been 1, 7. Okay. This is these two put together. The second and third that I am just going to discuss, these two put together are called range brackets. Okay. These two put together are called range brackets. Okay. Now, the first range bracket is 1, 7. The first range bracket is 1, 7. Okay. Now, 1 is there as well as 7 is there. So that means the starting value is there and the ending value is there. when neither of the starting values nor the ending value is included. So that is why I can also call it as a excluded bracket. Okay, neither 1 is included nor 7 is included, so both of them are excluded and all the values between them are supposed to be taken. That is why it is called the range bracket. Okay, understanding my point? Any doubts? Right, so the next part is this bracket 2 comma 6. Now what does that mean? What does that mean? Guys, am I audible? What does that mean? Okay, I guess there's some video issue. I'll just correct it. I guess there is some video issue. Please wait for 1 minute.
I think it's ready now. Okay. So I guess I am audible now and visible as well, right? Okay. So this is the second range bracket that I prefer to call it. Okay. Now, in this, both 2 and 6 are included. Both 2 and 6 are included. And that is why both these range brackets will have 2, 3, 4, 5, 6 as a sequence of numbers in them. Right? Both of them will have 2, 3, 4, 5, 6 as the range of numbers, or the not actually the range, but the values that are supposed to be inside this. Okay? So that is why they are called what? Range brackets. Okay? So in the range brackets there will only be a initial term and a final term, then only we are reaching the number parameter. Okay, and all the values between them are supposed to be taken or included or excluded. Okay, now if this line would not have been mentioned, then all the values greater than 1 and lesser than 7 were supposed to be included here. Okay, so how do I define that as well? I use a number line here. Okay, so starting point is 1, the ending point is 7. Okay, I am trying to define this first. Okay, how do I define that? I am keep it open at 1 and keep it closed at open at 7. And I say that all the values between 1 and 7 are supposed to be taken. But all the values between 1 and 7 are supposed to be taken. This is when n is let's say a real number. So when n is a real number, then we are supposed to take all the values starting from 1 and ending at 7. Okay? Right? Right? So this is the first part. The second part, 2 to 6. If I am saying 2 to 6, if I have to define this, then how will I define it? I would say 2 will be somewhere here, 6 will be somewhere here. I would say 2 is included. Yes. 6 is included. Yes. And all the values between 2 and 6 were also included. So this would have been another way of writing the square bracket. Okay. So if something is included, you put use something like this and something like this, and if it is excluded, then you use the open part of it. Okay. So this is also called a open or a closed bracket. Okay. And obviously, to define a lot of functions, we can also use the combination of these. Okay. We can also use the combination of these. Okay. So how would this be defined as? This would be defined as 1 to 7, 1 being included, 1 is closed, but 7 is open. And how would this be defined as? 1 to 7, 1 being open and 7 being closed. And all the values between them being the part of our particular set. Okay. And how would we define it in this particular form? N or X, whatever it is, whatever value we are taking. If 1 is included, then something like this, and if 7 is excluded, then something like this. Okay. And how would this be placed? It would be n is such that n is 1 is not included, so open at 1 but close at 7. So this would be the right way of putting it forward. Okay? Understanding my point? So this was something about what is a set and how do we define them, and some introduction to that. Right? I hope the basics are clear. Now, when we define set, we also define the kind of sets or something called a portion of a set. So, set to subset. This is the second part that we need to discuss before we start the first question of ours. Okay? So, again I am repeating, if you want to understand what we are going to discuss in the first question of a subset, I would really request you guys to first please go back and see the session on PNC that we have discussed. Okay? The session on PNC will be of great importance when we will be discussing the first question of subsets. Okay? I will just explain why. when we will be discussing the questions. Okay, anyways, so what is subset? The way I like to write a subset is something like this. Okay, why did I write it something like this? Because according to me, A is the child and B is the father. Okay, A is the child and B is the father. Okay, something like this. Okay, so why? That A is the child of B, something like this. Okay, or A is the subset of B is how I would like to refer it as. Okay, so if B is having 3 elements in it, 1, 2 and 3. So B is having 3 elements, 1, 2 and 3. And I want to write here, or I want to say here that how many subsets can this particular set has. Okay, so let's imagine something like this. If B is a father and he has 3 properties, so how many properties can A take from B? How many properties can A take from B? Is my question, right? So B can take, A can take none of the properties. So that will be defined as a this or this. Okay, empty set. Okay, if I take none of the properties, if child takes none of the properties from his father, then that is the empty set, nothing will be there inside it. Right? Now, the second portion and second part which can happen is it takes one of the properties. Okay, it takes one of the property. In the chapter of ANC, how would I write this particular sentence? When none of the properties have been taken, there are 3 properties in total, out of which I am selecting 0 properties. That is called 3C0. Okay. The second part is when I am selecting one of the property, which can be either I can take the first property, or I can take the second property, or I can take the third property. So that will be 3C1. What will be 3C2? If the father has 3 properties and the child chooses to take any of the 2 properties. Okay. So that will be 1, 2, 2, 3 and 1, 3 and 1, 3. Okay, so that will be the second part. Understanding your point? Any doubts here? Perfect. So the third part is 3C3. The child takes all the 3 properties, 1, 2, 3. Okay. So how many options do I have? How many options do I have? 3C0 or in place is called plus. 3C0 means out of 3 properties the child takes one of the properties. Out of 3 properties the child takes one of the property. Out of 3 properties the child takes 2 of the properties, and out of 3 properties the child takes all 3 of the properties. Okay. So this will be the sum total of number of cases here. So how many? What are the number of cases which are there? 1, 2, 3, 4, 5, 6, 7 and 8. And that is why in POC we discuss Okay, let me check. Thank you, sir. So is it better now? So is the echo problem issue resolved? As of now, so there is no background noise actually. हेलो, यस सर। हाँ, अभी मैं कुछ देख रहा था तो सबसे पहले सर मुझे बंद कर दिया है। सर इनको आप अभी चेक करें। Please reply for my meeting.
Is the audio better now? Is the audio better now? Is the audio better now?
Is it audible now? Is it audible now?
I guess the audio issue is now resolved. I guess the audio issue is now resolved. Right? Can we start? Please reply so that we can start. Sorry for the inconvenience, guys. I'll repeat this particular last slide again. Please reply so that I can start the session, guys. I'll repeat the last part. Thanks, James. Thanks, James. Sorry for the inconvenience. Okay, so what I was discussing basically, James and everybody else, was the definition of what is a subset. The definition of what is a subset. Okay, the subset, how I would like to call it as, is if I say that A is a subset of B, then the other way of putting this particular statement is A is the son of B. A is the son of B. Okay, so how do I call A is the son of B? Something like this. A is the son of B. So something like A is the son and B is the father. Okay, A is the son and B is the father. So if I define B as the elements 1, 2 and 3. So the son, how many properties of his father can the son take is how would I like to call it. Okay, so that would be the how many subsets of A are possible. How many subsets of A are possible is how I would like to define it as. Okay, so the first option of A taking is neither of the properties. That would be called a empty set. So the empty set is defined either by this or by this. So A can take neither of the properties of his father. That is one option. In the chapter of PNC, we call this as out of the three properties, the son is taking zero properties. So I would like to call it as 3C0. A can also take one of the properties of his father. A can also take one of the properties of his father. That would be called 3C1, choosing one out of three. NCR is called choosing R out of 3 or N, sorry. So, uh, so A can take one of the three properties. How? He can either choose one property, he can either choose two property, or he can choose the third property. So these would also be an options, right? What would be the third option? Taking any of the two properties, taking any of the two properties of his father. Okay, that would be called how? 1, 2, 2, 3, or 1, 3. That is the third option. And the last option is 3C3. That is taking all the three properties of his father. Taking all the three properties of his father. Okay. So that would be the last option, guys. So in total, how many options are there? Empty set 1, 2, 3, 4. So this was one option here. 3C0 that means is 1. 3C1 that means is 3 because there are 3 options here. 3C2 are also 3 and 3C3 is 1. So if I add them up, I'll get 8. If I add them up, I'll get 8. So in total, there are 8 options, that means. Right? Right? In total, there will be 8 options. And that is a property of PNC that we have discussed, which is NC0 plus NC1 plus NC2 plus so on till NCN is nothing but 2 to the power of n. Is nothing but 2 to the power of n. Okay, and that is why 3C0 plus this or this or this or this in PNC or means plus. In PNC or means plus. Okay, so NC0 plus NC1 plus NC2 plus NC3 and so on till NCN was 2 to the power of n. So 3C0 plus 3C1 plus 3C2 plus 3C3 would be 2 to the power of 3, guys. 2 to the power of 3. Okay, so this is what we call a subset. Okay, so these are, what is the formula? The number of subsets is 2 to the power of n if number of elements in the set A are n. Okay, so number of subsets in the set B, sorry, because these are subsets of B, right? Okay, this is how I define the cardinal number of set A. Set B here. Okay, so if the set B is, let's say, 1, 2, 3, then the cardinal number of set B would be 3. That is number of elements that are in the set B. Okay. So number of elements in the set B would be equal to 3. Okay. I guess it's clear. Please reply in the chat box if there's any doubt. So the formula of number of subsets came out to be 2 to the power of n. And how did I derive it? Using this. Please reply if there's any doubt. Number of elements in the set. Okay. Now we need to define one more thing, which is proper subset. Okay. So proper subset is actually the old school thinking, where it used to be said that the son cannot have all the properties of his father. So it only says, if I come to define what is a proper subset, then I say taking none of the property is okay. Taking one of the properties also okay. Taking two of the properties also okay. But taking all the properties is not allowed. Taking all the properties is not allowed. So, how many proper subsets would be there? If the number of subsets, if the number of elements were n, then the number of subsets were 2 to the power of n. Proper subset says A becoming equal to B is not allowed. A becoming equal to B is not allowed. So, the only one set where A becomes equal to B was not supposed to be taken. And that is why the number of proper subsets, the formula would become 2 to the power of n minus 1. The formula would become 2 to the power of n minus 1. I hope it's clear. Right? Any doubts, please reply. So the number of proper subsets would be 2 to the power of n minus 1. Now, which element was not supposed to be taken? This one, when A becomes equal to B. Now, you should also know what is a equal set and what is a equivalent set. If the number of elements in A and the number of elements in B becomes equal, then that is called a equivalent set. Okay. So something like if A set is A comma B comma 1 and the B set is 2 comma 3 comma 4, let's say, then these two sets are equivalent because the number of elements in both of them are equal. Okay. What is the equal set? The equal set says the number of elements in A and the number of elements in B are supposed to be equal. That means every equal set is supposed to be equivalent first. At the same time, all elements in A must be in B and all the elements in B must be in A. So I said vice versa. Okay. So all elements in A in B and all elements of B in A. Okay. Then that set would be called a equal set. That means they have all the elements are the same only. Okay. So the example of that would be A is equals to B is equals to, let's say, 4 comma 5 comma 6 comma 7, let's say. Okay. So this is an example of what? A equal set. This is an example of what? A equal set. Okay. So proper subset says that A and B should not be equal. This is what a proper subset says. Okay. So subset is defined by this. That means A being equal to B is allowed. Proper subset says something like this. Proper subset says something like this. Okay. So this was how to put it forward. Okay. Now let's see the questions, and based on the question, we'll try to see the solutions now. So set S is having 11 elements: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. Now, how many subsets of S are there? We have just discussed the number of subsets is nothing but 2 to the power of n. So, if it is having 11 elements, so the answer would be 2 to the power of 11. Okay. One suggestion or one thing is that you should remember what are the powers of 2 till 11 or 12, sorry, actually. Okay. And the best way to know what is 2 to the power of 11 is 2 to the power of 10 is 1 GB kind of a thing, right? Because in 1 GB there are 1024 MB, right? If any of you is a computer engineer or uh, is anyways related to studies of computers, and somehow everybody should know this, right? 1 GB is 1024 MB. Okay. So 2 to the power of 10 is 1024. So 2 to the power of 11 would be the double of that, 2048. Just a way to remember it. Okay. Now, how many proper subsets? Again, simple question. 2 to the power of 11 minus 1. 2 to the power of 11 minus 1 would be the total number of subsets that there are. Right? 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 So, the third part. How many subsets of S contains at least one even number? So, at least one. At least one even number. The best way to solve such a question can be, as I discussed in the PNC portion. In PNC, I took the special cases formula to be equal to total cases subtracted by not possible cases. The cases which are not possible. Okay. So if it is saying at least one even number, that means which case is not possible? That all of them are odd. So if I take the total cases and subtracted by all the sets having all odd numbers. Okay, this was the only thing which was not allowed. At least one should be even. So what is not allowed at all? That none of them is even. And none of them being even is all odd numbers. So the total cases would be 2 to the power of 11. The total number of subsets in total are 2 to the power of 11 because the set is this for that. Now, if I need to take all the odd numbers only, then that means what would be the set I have to actually take the number of subsets of. Let's say I've defined it as A to be 1, 3, 5, 7, 9, 11. Right? So the set A I'm now concerned about is what? 1, 3, 5, 7, 9, 11. Right? So that would be how much? If there are 6 elements, the number of subsets which has all of them odd, the answer would obviously be 2 to the power of 6. So if I subtract 2 to the power of 11 by 2 to the power of 6, I'll get my answer. Right? 2 to the power of 11 is 2048. 2 to the power of 6 would be 2, 4, 8, 16, 32, 64. So minus 64. So 2048 minus 48 would have been 2000. And it is further 16 below than that. So that would be 1984. Okay. That would have been 1984. Any doubts? If there's any doubt, please reply in the chat box. Okay. How did I define this in the chapter of PNC? Okay. How did I define this particular thing in the chapter of PNC? I said, let's say I took an example. I'll just repeat the example for you. If there are 12 members, okay, out of which 8 of them are women and 4 of them are men. Okay, 8 women and 4 men. Now, if I need to make a committee of 3 members, okay, 3 special committee is to be formed. Okay, and I say that there should be no men. The first question: in how many ways can I make a special committee with no men? So what would be my answer? It would be, if there are no men to be taken, that means I have to take all the 3 members from the 8 women that are there are. So the answer would have been simply 8C3. Choose any of the 3 members from the total number of 8 members, 8 women members, right? If I say at least one man, at least one man, so what you would have done? Then the options that you can think of are one man and 2 women, or 2 men, 3 and 1 woman, or 3 women, sorry, 3 men. These are the 3 options that you could have thought of, right? So you need to add these 3 values. Just imagine if a committee of, let's say, 5 members was supposed to be formed, and at least 1 woman should have been there. So don't you think you had to do a lot of work adding 5 of the options, right? So this is one way of thinking, or the second way of thinking is take the total cases and subtract it by not possible cases. What was the only case which was not possible? No men. The committee having no men was the only case that was not supposed to happen. So the total cases, the answer was, if there was no restriction, then out of the 12 members, irrespective of they are men or women, I need to take a committee of 3 members. So 12C3 minus no men means this. That means out of the 8 women there are, I have to select any 3. So 12C3 minus 8C3 would have become my answer. Okay. This is just the similar case that I just discussed with you for this particular question of how many subsets of S contains at least one even number. Means total cases minus the special case when there were no even numbers actually. Okay. Fourth question now. Okay. Just a revision. Fourth question. How many subsets of S are there in which at least one of 2, 3, 4 is there and at least one of 5, 6, 7 is not there? Okay. So I'll just again, first I'll take an example and then I will explain the question to you. Okay. Let's say I have some school friends. I have some college friends. And I have some office colleagues. Okay. In office, one philosophical thing that whatever friends you have made, the best of the friends would have been from school. The friends can still be the long lasting friends can still be from college, but in office there are no friends. You can never form a friend. Okay, they are only colleagues, because it is a cutthroat world you are going to enter into after your MBA is done. Or if you are already not a fresher, then you must have experienced this. Okay, so if A, B, and C are my school friends, if D, E, and F are my college friends, and X, Y, Z, W, and P are my office colleagues, and I need to throw a party, and my wife says that if you are throwing a party, what is she saying? At least one of your school friends should be there. You have to call. At least one of the school friend you have to call. Okay. Do not call all of your college friends. Okay. Right. And regarding the office colleagues, she says, do whatever you want. Okay. Do whatever you want. That means you can call none of them. You can call all of them. You can call one, two, three, four, or five of them. Anything you want to do, you do it. Okay. Because she knows that I am related. I'm more linked to my school and the college friends. And she don't want all my college friends to be there. So in how many ways can I do that? So what are the thinking process that would go on? I'll pick up my phone and say A is my first college friend, school friend, sorry. So should I call him or should I not call him? So how many options do I have? I have two options of either calling A or not calling A. Then I'll think about B. Again, I have two options of calling B or not calling B. Again, I have two options of calling C also, calling C or not calling C. So in total, I had 2 to the power of 3 options, right? But at least one of them I have to call. So I subtract that one particular case when I called neither of them. Okay. So how would I define this particular thing as? 3C0 plus 3C1 plus 3C2 plus 3C3 was supposed to be equal to 2 to the power of 3. Now what I was not supposed to do, I was supposed to call at least one of them. So at least one means call 1, call 2 or call 3. So if this is something I need, that means my answer is supposed to be 2 to the power of 3 minus 3 to the 3C0, and 3C0 is 1. So it would be 2 to the power of 3 minus 1, and that would be 7. Okay. And this was 7, that means. And in PNC means multiply. Now, coming to the college friends. I had 3 friends. I'm supposed to not call all of them. Then, actually what it means here it means do not call all of them. So, call none of them is okay. Call one of them is okay. Call two of them is okay. What is not okay? Calling all 3 of them. So, the answer to this would be 2 to the power of 3 minus 3C3. That would again be 8 minus 1. Because 3C3 is 7. 3C3 is, 1. Okay. So, one thing you need to remember is NC0 is 1. NC1 is all, NC1 is n, and so on. NCn is also 1. Okay, right? Okay. NC2 also I'll define. NC2 is n into n minus 1 upon 2. Just for your understanding. Okay. One more thing that you should always remember is NCR is same as NC n minus r. NCR is same as NC n minus r. Okay. So do not call all of your college friends. Do not call all of your college friends means again 7 only. Okay. 2 to the power of 3 minus 3c3. Okay. Now do whatever you want for the college friends. Again, I had 2 options for this, 2 options for this, 2 options for the third one, 2 options for the fourth, and 2 options for the fifth. So that means the answer would be 2 to the power of 5 here. Yes. I don't have to subtract any part of it. So this would be my answer. Here also the answer was 2 to the power of 3 minus 1, because 2 option for this, 2 option for this, 2 option for this, minus that 1 option when I called all of them. And here minus 1 was for of calling neither of them. So what would be my answer? 7 into 7 into 2 to the power of 5. This is exactly the same as the third question, guys. Or fourth question, guys. How many subsets of S are there in which at least one of 2, 3 and 4 is there? So at least one of 2, 3 and 4 is there. So how many options do I have? 2 to the power of 3 minus 1. Second case. And at least one of 5, 6, 7 is not there. So what I'm not supposed to do is having all of them. So 5, 6, 7. At least one of 5, 6, 7 is not there. So the answer would be 7 ways. Okay. I have just explained the same thing to you. Okay. And the third case is regarding all the other numbers apart from 2, 3, 4, 5, 6, 7. So they would be 1, 8, 9, 10 and 11. Right? So the total number of ways of taking 2 to the 2, 3 or 4 would be, the number of subsets from 2, 3 or 4 would be 2 to the power of 3. Minus 1 was for not taking any of them, multiplied by at least one of them should not be there. So again there are 3 elements. So the total number of ways, the total number of subsets that can be formed with the help of 5, 6 and 7 was 2 to the power of 3, because the number of subsets formula is 2 to the power of n. And minus 1 was for when I called all of them. And the remaining elements were 1, 8, 9, 10, 11. So out of these 5 elements, how many subsets can be formed? 2 to the power of 5. And this would become my answer. Now 7 into 7 into 32, obviously 49 into 32 it would become. You can solve it yourself. Okay. This part you can solve it yourself, right? I don't think I need to explain how do you multiply 49 and 32. Okay. If you don't know how to multiply in a single line, then I will explain it. For those students who do not know how to multiply it in a single line, I'll just explain it to you. The method is multiply the unit digits of both. So 9 into 2, 18. Then multiply the mean or the closer ones and add it to the farther ones and add carry to it. Okay, so 9 into 3 was how much? 27. Okay, 27 plus how much? 27 plus 4 into 2 was 8. So 27 plus 8 would be 35. 35 plus 1 carry, 36. So now the new carry would be 36. Now multiply the tens places of both of them. Now multiply the tens places of both of them. So that would be 4 into 3, 12. And add 3 carry. So that would be 1568. Okay. 1568 would become my answer. Understanding my point? Now, coming to the next question. How many subsets of S are there which contains 2 if 5 is also there? Which contains 2 if 5 is also there. Now, this is a very important logic which we do discuss in the chapter of binary logic and connectives. Okay, and what is that? How many subsets of S are there which contains 2 if 5 is also there? Okay, I'll just make some space so that because of my face you are not able, if you are not able to see the questions, then it shouldn't happen, right? Perfect. So let's try to do it now. It is saying contains 2 if 5 is also there. So among 2 and 5, what are the options do I have? Taking both of them, taking this, not taking this, taking this, not taking this, and taking neither of them. This is all I can do about. This is all I can do about choosing among 2 and 5. So what is my thought process is 2 comma 5 make the combinations. Apart from 2 comma 5, that would be 1, there would be 3, there would be 4, there would be 6, there would be 7, there would be 8, there would be 9, there would be 10, there would be 11. Okay, in total there will be 9 elements. So how many options I have of making the subsets using these 9 elements? The total number of answers would be the total number of cases would be 2 to the power of 9. And among 2 and 5, what are the possible options that I can take? Okay, what are the possible options? A contains 2 if 5 is also there. So if 5 is there, then 2 should also be there. Okay, if you are taking neither of them, it is okay. But if 5 is there, then 2 should be there, na? So this is not possible. If 5 is not there, 2 is there, that is possible, guys. So among these 4 options, see, this was 2 to the power of 2. This was 2 to the power of 2. Among these 4 options, which option I could not have taken? Only one. Which option I could not have taken? That was only one case. Okay. So the answer would be 2 to the power of 2 minus 1 multiplied by 2 to the power of 10. 9, sorry. Because 2 to the power of 10 is 1024. So 2 to the power of 9 would be divided by 2. That would be 512. And this would be 4 minus 1, 3. So 3 into 5 and 2 would become my answer. Okay. So 3 to the 6, 3, 1, 5, 3, 6. So 1536 would become my answer. Any doubts? Please reply in the chat box. Now, coming to the next part. In how many subsets of S are possible such that if 6 is there, then it must be the highest? Okay, a very good question. See, there are two options of taking a 6 or not. Right? 6 is there or 6 is not there. You can take only two things. Okay. How many subsets you can form with the element of 6? 2. 2 to the power of 1. Okay. Take 6 or do not take 6. If 6 is taken, then it must be the highest value. Then that means 7, 8, 9, 10 and 11 should not be there. Okay. So how many options do I have? 2 to the power of 6. No. If 6 is there, then you don't have a choice of taking 6 or not taking 6. So actually, the other elements that can be there or cannot be there would be 1, 2, 3, 4 and 5 only. So the answer would not be 2 to the power of 6 but 2 to the power of 5 multiplied by 1 for the choice that I had for 6 was only one choice, and that was yes, I had to take 6. Okay. And if 6 is not there, then what are the other options I have? I have all the other 10 options. And that would be 2 to the power of 10. And that would be 2 to the power of 10. Okay. 2 to the power of 10 is 1024. 2 to the power of 5 is 32. So the summation of that would be 6, 5, 1056. So 1056 would become the answer to this particular question. Okay. So anything and everything you need to discuss or know regarding this particular chapter was this. Understanding? Any doubts? So coming to the next part. Okay. Before discussing the next part, I need to discuss some basics about the new concept or the basics of Venn diagrams. The basics of Venn diagram. Okay. What are the basics of Venn diagrams? What are the basics of Venn diagram, guys? Now, in Venn diagrams, when there are sets, okay, there is a universe, that is basically the I should say the father, okay, and the father here is a universe denoted by the sign of mu. Okay, this is the sign I would be using a lot, so please note it down. Okay, the universe is defined by the sign of mu. Okay, and all the children of the sets of this particular set is would be denoted by the use of circles. Okay. Now, one thing that we discussed in the part of probability was there are two types of in, relation between the two sets, and that can be mutually non-exclusive and mutually exclusive. Okay, mutually non-exclusive means they don't have anything in common. Oh, sorry, they have anything in common. Mutually exclusive means they have nothing in common. Okay, for example, if I throw a dice, okay, and I say I get an even number or I get an odd number. So in a dice there is 1, 2, 3, 4, 5 or 6. Okay, so the even number options are 2, 4 and 6, and the odd number options are 1, 3 and 5. Right, they are 1, 3 and 5. So how many options do I have? All the options are covered in this particular circles. Okay, is there any common portion? Is there any number which is even also and odd also? No. So they are mutually exclusive, they have nothing in common. Okay, but in the same case of a dice roll, if I say even number and prime number, okay, then the even numbers are 2, 4 and 6, and the prime numbers are 2, 3 and 5. Okay, so the prime numbers are 2, 3 and 5. Now you would say that there is one particular element which is not there, which is neither even nor prime, and that is 1, guys, in a dice roll. So where will we place 1? Outside it, inside the universe, but outside these sets. Okay. So I have actually formed how many regions would be there in a two set Venn diagram. Only even numbers is one portion. Okay. If I define this as A set, this as B set. So what are all the portions that I get? Only only even numbers, or only prime numbers, they would be 3 and 5, or both even and prime, that would be this particular value of 2. Okay, and this would make plus neither actually would be defined as mu or the universe. Okay, would be defined as mu or the universe. Understanding my point? Right. Now, in the case of PNC and Venn diagrams or set theory, the sign of and is multiply or is plus. In the chapter of Venn diagram and set theory, this and is defined by intersection and or is defined by union. So both A and B would means A intersection B. Okay, first thing first. Okay, now how do I define A or B? A or B would be defined as A union B. Okay, so A or B would be defined by one way would be only A, only B plus both A and B. These three portions would actually be A union B's first definition. Only A plus only B plus both A and B. The common portion of all of them would be my first definition. Okay. Suresh, please reply, beta. Suresh, please reply. What is the portion that you are not able to understand, beta? What is the portion that you are not able to understand? Please reply. Just write it. I wasn't seeing the session chat box for some time, so it's okay. Please reply now. What is the portion that you did not understand? Okay, I'll explain it to you again. Anything and everything that you have not understood, please reply. I'll be more than happy to make you understand. Sorry for not able to see the chat box for some time. Okay, now A or B is A union B. A or B is A union B. Now, if I need to define it, I say I'll put A, I'll add A and B's set first. So the circle of A in this had how many elements? Had 2, 4 and 6. Had the elements of 2, 4 and 6. Okay. So if I put 2 comma 4 comma 6 here, okay, and I also put circle of B, which is 2, 3 and 5. 2, 3 and 5. So what happened was I get I get 2 double time. So what I am getting double time, I have to subtract it. Okay. So if I subtract this by A intersection B, if I subtract this by A intersection B, then what will happen? A intersection B is a common portion of both of them. Is a common portion of both of them. Okay. And what is the common portion of both of them? It is 2 only. So 2 I was getting 2 times. So if I subtract 1 time of it, what I get? I'll get 2, 4, 6, 3 and 5, which are all the elements being taken one at a time. Only one time only. Okay. All the elements taken only one time is the way I would define it. I hope it is clear. I hope it is clear. Understanding? So this becomes my formula of A or B, or A union B. Okay. This becomes the formula of A or B, or A union B. Okay. I'll just explain for you, Suresh, one more time. A, B. In A, there are, if A, small a is a subset which has only A. Small b is a subset which has all the elements of only B. C is a subset which has both A and B. Okay. So only A is denoted by A. This is only A. Okay. It has nothing to do with the portion of B. Okay. So only A is this much. Only B is what? Small b. So this was only B. Okay. Both A and B was C. Both A and B was C. Right? Which is also defined as A intersection B. Okay. So A union B is actually all the shaded portion there is right now in front of you. So A union B would be all the shaded portion there is, that is the universe of the circles. That would be called the universe of the circles. Right? So that is supposed to be A plus B plus C. Right? The universe of the circle is supposed to be A plus B plus C. So if I say I add A plus B here, then that what does that mean? A set means A plus C. B set means B plus C. So when I add these two, what will I get? I'll get A plus C plus C plus B. I'm getting C 2 times, right? I need to subtract it by A and B, which is C, so that the extra C gets removed. So the extra C gets removed, so I get A plus B plus C again. Okay. And this is the definition of A union B, which is A plus B minus A intersection B. Okay. The another definition was only A plus only B plus both A and B also. Okay. I hope now it is crystal clear for everyone. If you have any still have any doubts, please reply in the chat box. I'll be more than happy to help you out. Okay. Now I'll try to do one particular question and then we'll come back to 3 set problems also. Okay, we'll come back to three set problems after we have done the questions. Okay, at least a couple of questions. There are certain number of students in a university class. Okay, of all 25 students play hockey. Of all, okay, so this is a three set problem actually. 25 play hockey, 12 play cricket, and 18 play football. Okay, so let's go back and discuss three set problem first. So, a three set problems. In set theory, in Venn diagrams, what happens is if the number of sets there are and the number of regions are related by if the number of sets are n, so the number of regions would be 2 to the power of n. If there is one set, there will be two regions. Example, one set, two region, portion of A and not the portion of A. That would be outside A. Okay. If there are two sets, then the number of regions would be 2 to the power of 2. Okay. Only A, only B, both A and B, and the outside portion, that is neither. Okay. So there will be four regions. Okay. A, B, C, and X. So these are the four regions being talked about. A, B, C, and outside this X. Right? If there are three sets, then there would be 2 to the power of 3. 8 regions would be there. And this is what I am just going to discuss right now. A set, B set, and C set. Okay. The whole circle of A would have four regions, right? First portion would be only A. Okay. Second portion would be this much. Right. The third portion would be this much. Right. The fourth portion would be this. Okay. So there are four portions here. Okay. Only A, only A. Okay. This red one, this green one, and this orange one. Okay. I'll explain one by one all of what it means. Okay. First, only one portion is defined by three portions: only A, only B, and only C. Okay. So the only A portion is called small a, only B portion is called small b, only C portion is called small c. Okay. So I'll just write it down. Only A, only B, and only C. So only B was this portion. Only C was this portion. Okay. Now the next portion comes, the next extreme portion I can call it, is all three. All three portions is the common portion of A, B, and C. That would be called A intersection B intersection C. And that would be the G portion, the orange one. Okay, so this is my G portion, the orange one. Okay. The next portion is only 2. Only 2 means exactly 2 of these 3. That would be A and B, B and C, and C and A. Okay. So A and B Only 2 means A and B but not C. B and C but not A. C and A but not B. Let me call these as D, E and F portions. Okay. A and B but not C is denoted by this red portion, right? A and B but has nothing to do with D. C, sorry. The next portion is A and C but not B. A and C but not B is denoted by F, which is the green portion. Okay. And the last portion is this portion. And the last portion is this particular portion, E, which is B and C but has nothing to do with A. Okay. If there's any doubt, please reply in the chat box. Any doubts, please reply in the chat box. Okay. So, how many portions were I able to define? Only one, there were 3 portions. Only 2, there were 3 portions. All 3, there was 1 portion. And neither. And neither, there was 1 portion. Please wait, guys. Hello. अच्छा, अभी भी कर रही है? नहीं, वैसे तो वाईफाई में है. ठीक है, ठीक है, ठीक है. नहीं, वैसे तो वाईफाई में. I guess I've just checked the audio and the video are correct. Right? Okay. So this was all 3 portions. Okay. And the last one is the neither portion. The last one is the neither portion. Okay. So the last one is the neither portion, which is the outside portion, guys. Outside to these circles. Okay. The universe which exists outside these circles is called the neither part. Okay. That would be called the neither part. Okay. That is X. So if I again try to compare it with PNC, what I will say? This is only one, that would be 3C1. Only 2, that would be 3C2. All 3, that would be 3C3. And neither would be 3C0. And the summation of these 4 values is supposed to be 2 to the power of 3, that is supposed to be 8. That is supposed to be 2 to the power of 3, and that is 8. Okay. I'll just reconnect.